So in this lecture we are going to see some more problem examples of relations. So I will start with an example. So my first example would be let A is a set of numbers 1, 2, 3, 4 all the way up to 14, and the relation R is defined as xy pairs such that 3x minus y is equal to 0, where x and y belong to A. So now we have to write the domain, codomain, and range of R. So first we have to find R, that is we have to represent R in the tabular form or roster form. So 3x minus y should be 0. So 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 here so R is defined from A to A itself. So all the first elements here should be element of A, and the second element should also be elements of A. So we will start taking examples like suppose first I take 1, then 1 minus 3 into 1 minus 1 is not 0. Then we will take 1 and 2. So 3 times 1, 3 minus 2 is not 0. Now we will take 3. So 3 minus 3 is 0. So we will go with that. So basically you clearly see that this will be true when, so we have to find 3x minus y should be 0. So y should be equal to 3x. So this y is the second element here. So we have to find xy such that y equal to 3x, and both x and y both should belong to this set A, that is both should be numbers from 1 to 14. So now we can directly fill in the numbers like 1, 3. So the first element, the y is 3 times the first element. So for 1 it was 3, for 2 it should be 3 into 2 6, for 3 it's 9, for 4 it's 12, for 5 it will be 15, but we have to find only numbers less than 15, so we are done with it. So we have found the relation R. Now what are the domains? Remember, domain are all the first elements of the pair, ordered pair. So domain is 1, 2, 3 and 4, and range is 3, 6, 3, 6, 9 and 12. So we will write that domain equal to 1, 2, 3 and 4, range equal to 3, 6, 9 and 12. Now codomain. In our earlier class, we had seen that some of these elements will be images of some of elements here, but we will have some other elements here which will not have any image pre-image corresponding to these. So this entire set we were calling it codomain. So here both these are, this relation is from A to A. So the entire A set will be the codomain equal to A equal to 1, 2, 3, 4 all the way up to 14. So now I will take second example. So in this relation R is defined. So our relation is x comma y such that y is equal to x plus 5 and x is natural number less than 4. X comma y both belong to n. So both are natural numbers, x and y. So write in raster form, find domain and range. So this is the relation that we are given, and x is less than 4, natural number less than 4. So x, what values it can take? It can take 1, it can take 2, it can take 3, but it cannot take 4 because it should be less than, not less than equal to. So x can take only 3 values. So now we can write R. So the x, this first element of every ordered pair, it can take values 1, 2 or 3. So if we write 1 here, y should be x plus 5. So it will be 1 plus 5, that is 6. Then if we write 2 here, then it should be 7. And if we write 3 here, then it should be 8. So this is our relationship. And what's the domain? Domain is always is the set of all the first elements in these ordered pairs. So the first elements are 1, 2 and 3, and range is the set of second elements of all the ordered pairs. So here we have 6, 7 and 8. So we will write 6, 7 and 8. So sometimes we are asked problems like here we are defined one relation R. So we have also found what's R in the roster form. So sometimes we are asked find inverse of R. So it's also written as, if our relation is R, then R inverse will be denoted as this R inverse. So we don't need to redefine the relation. So if we have this R, then this R inverse will have all the, we can flip flip both the elements of each ordered pair xy of R. So our R inverse would be, so our R inverse would be, we can calculate it directly from this R. So our first element in R was 1 6, so we can write here 6 1. Then second element was 2 7, so we will write here 7 2. Third element was 3 8, so we will write here 8 3. So if we have to find R inverse, we will simply flip x and y for all the elements, for all the pairs. We will get R inverse. So that was our second example. So we are given, suppose we are given one arrow diagram. It has elements 5, 6 and 7. So this is, let's P, and this is Q, and here we have elements 3, 4 and 5. Five is mapped to 3, 6 is mapped to 4 and 7 is mapped to 5. So this we are given. So we have to find what's the relation. First we have to write the relation. In one set builder form, second roster form, then find domain and range. So clearly we see that 5 is mapped to 3, 6 is mapped to 4, 7 is mapped to 5. So 3 is 2 less than 5. Here 4 also is 2 less than 6 and 5 also is 2 less than 7. So if so x should belong to P, y should belong to Q, and we are given x and y. So from diagram itself we can directly write roster form. So this roster form we can directly write by looking at the diagram. So first I will solve the second one, roster form. So clearly, so we are given three pairs, three arrows we are from P to Q. So we can say that there are three ordered pairs. So we will write the pairs. It's 5, 3, 6 is mapped to 4. So next pair is 6, 4. Next we have 7, 5. So from diagram we can directly write the roster form. So we can write set builder form using the roster form that we wrote here. So R, we have to write XY and then the condition. So the condition is that this first element is 2 more than second element. So this Y, second element is Y, is 2 less than first element, 2 less than X. So Y is X minus 2. And we can also write X is equal to, or for X equal to, X is either 5, 6 or 7. Or we can write it as second condition, X belongs to 5, 6, 7. So this will be the set builder form. This will be the roster form. Now we have to find domain. So what is domain? Domain will be the set of all the first elements of the pairs. So it will be 5, 6 and 7, and range will be all the second elements of the pairs. So it will be 3, 4 and 5. So this completes our problem. So we will see one more example. So we are given a relation R defined as x comma x plus y, such that x belongs to 0, 1, 2, 3, 4, 5. We could have also written this as x equal to xy, such that y equal to x plus 5, and x belongs to 0, 1, 2, 3, 4, 5. So both are same thing here. This we are denoting as y. So we are defining one extra condition, y is equal to x plus 5. So these are both same things. So this we are given, and we have to find domain and range. So x is only, this is small set. X can take either 0, 1, 2, 3, 4 or 5. So we can write R and this second element is 5 more than this. So we don't even need to find this R, but for the sake of completeness I will write it. So 0, 5 more than 0 is 5, then 1, 6, 2, 7, 3, 8, 4, 9, 5, 10. So its domain would be all the elements. So basically this we can find plus 5 corresponding to each element. So all of these uh, elements will have some y. So all these are part of the domain, or we can see from here 0, 1, 2, 3, 4, 5, all of these. So its domain would be 0, 1, 2, 3, 4 and 5, and range would be all the second values of this relation. So the second values are 5, 6, 7, 8, 9 and 10. So we will write 5, 6, 7, 8, 9 and 10. So we will see one more example. So we have a set A which is equal to 1, 2, 3, 4, 6. And R is a relation on A. So if we say relation from A to B, then our first uh, domain will be subset of A and range will be subset of B. But if we write relation on A, then it's basically same as relation from A to A. So we also write just relation on A means relation from A to A. So R is a relation on A, and it's defined as R is equal to AB pair such that so as I said here, both the elements of the pair will belong to set A only. So both A and B belong to A, and A divides B. So we have to solve this, and R in roster form we have to write. Second, domain of R, and third, range of R. So A divides B. So that is, if we divide B by A, then we get some number, proper number, some number, some integer. Like if we divide 6 by 3, then we get 2. So here if B is 6 and A is 3, then this will satisfy this condition. But if we divide 6 with 4, 6 does not come in the table of 4. So we don't get some proper divisor. Like it will be 3 by 2 or 1.5, we will get a decimal number. So here 4 does not divide 6. So we have to find all such pairs where A belongs to one of these and B also belongs to this set only. So if we take 1, then we have to find all the numbers which are divided by 1. So clearly 1 divides itself, then 1 divides 2, 1 divides every number. So 1 will divide 3 also, 1 divides 4, and 1 divides 6. And then, so we have taken this. Clearly here this should be, if we are, if any number divides some other number, this should be smaller than or equal to this b. So we don't have to look backward, like from 1 we saw 2, 3, and so on in this direction. So once we have seen paired 1 with every other number, we don't need to come back to 1 again. Like if we are looking now 2, if first element is 2, then we will only see in this direction, because clearly 1 by 2, so 2 does not divide 1. Similarly 3 will not divide 2, or 3 will not divide 1. So we have to look only in this direction. So now for 2, 2 divides itself. So we will write 2, 2. Then 2 does not divide 3, but 2 divides 4. So we will write 2, 4. Then 2 also divides 6. So we will write 2, 6. So we are again done with 2. We are done with 1. Now we will see 3. So 3 divides itself. So 3, 3. 3 does not divide 4. Then next 6, 3 divides 6. So we have seen this 3 also. Next we will see 4. So 4 divides itself. 4, 4. 4 does not divide 6. So we will not write that. Then last is 6. 6 only divides 6 in this set. So both A and B should be in this set only. So here for this we will see that both 1 and 1, 1, 2, 1, 3, 2, 4, 3, 6, any pair we pick, both A and B both belong to this set only. So this is our set R defined in raster form. Now what's the domain of this? All the first elements of the pair. So 1 we have already taken. Next is 2, then 2 done here, then 3 and 4 and 6. Similarly range will be all the set of second elements. So range is 1, 2, so we will write 2. We have also 3, we have 4, and we have 6. And we have covered all these because 1 has divided every number, so it has taken care of everything. So these are just repetitions. So this would be the range. So both domain and range are this A. So that's it for this lecture. In the next class we will be starting functions. So functions are a type of relation. So we will study more the definition and some examples of function in the next lecture. So thanks for watching.